Alrighty, everyone. So today we are looking at a new lesson. So this is lesson 2. So lesson 1, you looked at the beginning of the algebraic expressions, looking at variables. So make sure you understand the difference between algebraic term, the degree of a term, and a coefficient. So please make sure you understand that. And how many terms and coefficients there are in a expression. So make sure you really look at lesson 1 and get the understanding of it before we move on to lesson 2. And as always, if you have any questions, please let me know. So for today, our goal is to be able to relate words directly to algebraic expressions and those expressions back to words after looking at them. And then be able to look at algebraic expressions using algebraic tiles. So if you looked at the lesson section, there's a section that you can go on and look at algebraic tiles. And if you haven't done so, please do so. That's always a great way and another way to understand your learning. If we are in class, we would use like the actual blocks, but there is an online version, so it's always great to look at that. So today we're going to look at 2 more terms. So we're going to look at the difference between an algebraic expression and an algebraic equation. So an expression is made up of variables and constants along with algebraic operations such as addition, subtraction. Both expression and equation have that. But the difference here is that it does not contain an equal sign. Meanwhile, an equation does contain an equal sign. So please make sure you understand the difference between that. So for example, we can look at 7x plus b is an expression, or x plus 2 is an expression, or x to the power of 2 plus 14 plus 1 is an expression. But an equation, it could be like 2 plus 2 equals 4 because of this equal sign. Or we have x plus x equals 4x, that equal sign there. So that is the difference between an expression and an equation. Equation has the equal sign, expression does not. So by yourself, I want you to pause for a moment. Try to match the following expressions to the meanings in words. So pause now before we are able to match and find the answers. Okay, so once we have come back, we're going to go through them. So A, we have n plus 7. So if we were to look at all of them, a way to describe this in words would be number 3, the sum of a number and 7. So this n represents a sum of a number. Okay, n represents a number. And then and 7 means you're adding by 7. B, we have 7 minus n. So same sort of thing is going to be number 2. So a number less than 7. After that, we have C, n divided by 7. In this case here, same sort of thing. N is a number, and that's divided by 7. That would be number 7 here. D, we have 7n plus 1. So 7n plus 1, that would be D. In this case, that'd be number 1. So it's going to be 7 times a number, okay? Because we know here, in this case, the 7n is also equal to 7 times n. So that would be D up with 1. E, 7 divided by n. If we look at all of them, we have number 8. So 7 divided by number n. And then F, we have our 7 and then in brackets n plus 1. So F would be matched up with number 6. The reason for that, we have a number. We always do brackets because we follow the BEDMAS rules. A number increased by 1, then multiplied by 7. Then we have G, n minus 7, so a number minus by 7. In this case here, sorry, we've got to pause. Sorry, everyone. Just pause for a moment. Sorry about this, everyone.
If you're in the lunchroom, sure to be seated properly at a table, not standing around or sitting on the tables
Okay, so what you can do now, make sure you get all the answers correctly. So G and H, so a number decreased by 7, that's pretty straightforward. And then H, we have 7 times your N, so that is a product of 7 and a number. So make sure you have all those correctly. There's different ways that we can explain these algebraic expressions in words. As we continue on, one tool that we can use to represent the algebraic expression is using tiles. So what we're going to do is we're going to look at all these examples here, A, B, and C, and you're going to go through them and using tiles express our information. So we have 4x plus 5. So what we're going to do is we're going to use this in different ways. When we have a variable attached to a number, we're going to use probably bigger tiles than just a number without a variable. So our 4, we can represent it using the long tiles, and we're going to make 4 of them because we have 4 x's. And each side, inside of each of these, we need to put an x to represent that. Then with our 5, we need to represent that either different color, but we're going to use smaller ones and break this up. And when we can do that is represent those tiles by 1. So in this case, we can represent the following using these tiles. So I want you to pause now and try to complete this using the tiles. Alrighty, so same sort of thing as A. For B, you would just have 5 of our X ones. So I'm just, oops, wrong color. You can draw it the same way that I just did, or you can just do a long one and then break it up by 5s, but each of them have to have an X inside of it, and then the 4 has to be 4 smaller ones. But the thing is, inside of this, we need to make sure that we have our 1s inside of it. But in this case, because it's minusing 4, we have the -1 in each inside. Okay? And then next here, we can do a different color if you want. Let's do pink. In this case, we have 3 different values. So we have 3x to the power of 2 plus 4x minus 5. So we need to use another algebraic tile that's a little bit bigger. And so in this case, we are going to use maybe a square one, whatever you prefer. And in this case, we're going to do 3 large ones. And we need to put x squared inside each of them to represent, we need to represent how many we have. We have 3x squares. Then after that, we need to do our 4x. So we can do our long ones again. And always put your x inside of them. And then in this case, because we have -5, always pay attention to the sign in front, we need to draw 5 of them, just like we always do, but we're doing -1 inside of them because we're subtracting. So when we're looking at these expressions, always make sure that you're classifying them according to the numbers that they have. So if we have a monomial, mono means 1. So for example, we have 3x to the power of 2. Okay, so there's only one value. Binomial means 2. So we can have 2x plus 3. So we have 2 values there. Trinomial is 3. Okay, so we can do such as example C here. So we have -x squared plus 3x plus 2. We have 3 separate values. And then polynomial is any number. Okay, so we can do 16x plus 21y to the power of 2 minus 154xy to the power of 2 plus 7. So we have 4 different values here that cannot be grouped together. So when we look at algebra expressions, we look at it, can we group them together, or how are we going to look at it? Okay, so make sure you complete this. If you have any questions, please let me know. It should be pretty straightforward, but please let me know if you do have any.